Simultaneous equations are quite useful in quite a few situations where you've got two different equations and they meet at a certain point and you want to find where they are. Graphically, what's going on is that here we've got two straight lines, and if we want to find what these straight lines look like, we can rearrange them into the form y equals mx plus c, which is the equation for a straight line. Y equals minus 2x plus 18. And this one would be y is equal to x minus 6. Straight away we can spot what the gradients of these lines are. So we have a gradient of minus 2 and it's crossing at plus 18. So it's quite steep going down and it crosses quite high on the axis. And the other one has a gradient of 1 and crosses at minus 6. So it's going to do something like that. And we can see that they cross somewhere over here. Now we haven't drawn these graphs accurately, so it's not a very good indication of where it's going to cross. You could solve this graphically. You'd have to draw it perfectly accurately on some grid paper, or maybe with the help of a computer. But we don't really want to do this method. It's not really giving us a space to do it, so that kind of indicates we don't do that. There's a couple of methods we could do to do this. One of the most common methods taught in schools is that you either add or subtract the equations from each other. So you can label this as equation 1, you can label this as equation 2. And if you were to add both of these equations together, we have 2x add x, that gives us 3x. Then if we had y plus minus y, those cancel out. And we have 18 plus 6, that gives us 24. So 3x equals 24. Dividing by 3, we get that x is equal to 8. And then we can just look back at one of these equations up here, and we can just simply deduce what y is. So we have 2 times x, which is 8, 2 times 8 is 16, plus something equals 18, y must equal to 2. And we could do a quick check in the second equation if we want to. So we could use x as 8, y as 2, 8 minus 2 does give us 6. So these must be the solutions. And that solves the simultaneous equations. You can see it's not really much working out at all, and you get 3 marks for that. Another method would be to do solving them using substitution. This method works in harder simultaneous equations, so it's a bit more universal. It works with quadratics and circles, whereas this one's a little bit harder to apply in those situations. And it's also quite handy because you get a idea of what the graphs look like, and you would put them into y equals mx plus c, and if it is a bit more complicated later on, you don't have to do any more rearranging. So I'll probably take this second equation and I'll rearrange that so that that is x as a subject. X is equal to 6. I'll plus the y to get rid of that, so we have to add it onto this side. 6 plus y. Okay, so now I know that x is equal to 6 plus y. The key thing of simultaneous equations is that we want to eliminate one of these unknowns, because when there's two unknowns, we really don't know what they're going to be. And we can replace this x with 6 plus y. So instead of x, we have 6 plus y here, so 2 lots of 6 plus y. Add y is equal to 18. That's great because we eliminated one of the variables. Expanding these brackets out, we get 12 plus 2y plus y. I'm going to simplify this as I go, so that becomes 3y, and that's equal to 18. And if I subtract 12 from both sides, I get that 3y is equal to 6. Divide by 3, I get that y is equal to 2, which is the same as what we had up here. That's good news. And now because I've already got this rearranged in the form that x is equal to something, it's just quite easy. I can just slot this 2 straight in. 6 plus 2, x must be equal to 8.